All right, good morning, everyone. We're going to go ahead and get started with our webinar this morning on Petrifilm use and interpretation. Thank you very much for joining us today. My name is Lauren Ellie, and I am the technical liaison here at Cherney. And with me in this webinar is Robert Brown, the client services manager. He'll be monitoring the chat as well as the Q&A, so feel free to ask questions and offer comments. Interaction is definitely encouraged. This session will be recorded and posted on our website later for others to view. So as we start with Petrifilm, I just wanted to go over the basics here. Petrifilm is composed of a top film and a bottom film. That top film is just going to enclose your sample, and the bottom film is composed of a foam barrier and a plating surface. So that what that foam barrier is doing is just to make sure that your sample stays within the plating surface. And that plating surface is composed of nutrients that are going to be specific to each type of Petrifilm that are going to help that type of bacteria grow, as well as indicators that are going to help you enumerate the bacteria present on that Petrifilm. And it also consists of a gelling agent, which helps so your sample will solidify and won't run off the Petrifilm plate. Making sure that your product is compatible with 3M Petrifilm plate is definitely an essential part before you start working with your samples on Petrifilm. 3M says that obviously they can't have evaluated all food matrices, all combinations of microbial flora, or all incubation conditions. So it's the user's responsibility to determine that any test methods and results meet the user's requirements. So with your product, you should identify if there are any issues with compatibility, and how would you verify if you did have issues. It's recommended that you would do a side-by-side comparison with your product on the Petrifilm and your product set up on an agar plate, just to make sure that those counts are similar. And if you had any large variances, 3M Petrifilm might not be your chosen method to go, as you might have issues with compatibility. As far as Petrifilm handling, your unopened pouches, when you receive them, they should be stored frozen or refrigerated. 3M recommends -20 degrees Celsius up to 8 degrees Celsius. You want to make sure that you use it before your expiration date. Those nutrients and indicators that I talked about initially can degrade over time. So it's a good idea to only keep on hand what you can use before the expiration date, and allow them to reach room temperature before you're opening and using your Petrifilm. For those open pouches, you're going to want to make sure that you seal the pouches shut after use, store them at room temperature, and avoid moisture. So make sure that you do not refrigerate those open pouches. You want to keep them in a low humidity environment, and use them within 4 weeks of opening, just to make sure that you use them within the optimal time range. Discussing buffers and growth inhibition. It does matter what buffers you use when you set up the 3M Petrifilm. They do not recommend using buffers containing citrates, bisulfate, or thiosulfate, as they can inhibit growth on your Petrifilm. When you're doing your sponging in your environmentals, try not to use the DE broth, the neutralizing buffer, or sodium citrate sponges, as they don't work very well with 3M Petrifilm. Acceptable ones would be lethine broth, high cap broth, BPB diluent, and a 0.1 peptone all work well with the 3M Petrifilm. You'll also want to keep in mind that the presence of inhibitory compounds like sanitizer are definitely going to affect your growth recovery on 3M Petrifilm. Uh, 3M Petrifilm requires a certain pH for optimal growth and recovery. You're going to want the pH of your sample suspension to be between 6.5 and 7.5. pH outside the recommended range could change that background indicator dye, which could be misinterpreted as TNTC or too numerous to count. When samples are not properly adjusted for pH prior to plating, that acidic environment can prevent your target organisms from growing on your Petrifilm. So pH plays a huge part when you're setting up 3M Petrifilm. So during your setup, you're going to want to place the film on a level surface. You'll want to just lift that top film aseptically and pipette your sample suspension onto the center of the bottom film on that plating zone. And then you're going to want to roll down the top film. Emphasis here on roll down the top film. Don't just let that film go, because that's going to trap air bubbles in your film, which is only going to cause you headache down the road during interpretation. Some of these Petrifilms, you have to see which colonies have gassing. And so if you have air bubbles that are trapped in there from setup, it's only going to cause you a headache. So do yourself a favor during setup and make sure that you're rolling the top film down just to avoid trapping those air bubbles in the first place. With the flat side down, place the spreader on the film and then gently apply pressure in the center of the spreader. Make sure at this point you're not sliding the spreader around. You just want to keep it in one place and apply that gentle pressure. Then you'll remove the spreader and allow that gel agent that I talked about in the beginning to solidify for 1 minute. "3M recommends that you incubate in stacks up to 20 films. Make sure that you incubate following your appropriate method. It's recommended that you count the colonies on the Petrifilm with a colony counter, and do not count colonies on that white area, the foam dam around the plating surface. Make sure you only count colonies within that surface. And it's also recommended to follow countable ranges. For those of you not familiar with countable ranges, those are found in a reference method from the Compendium of Methods for Microbiological Examination of Foods. Each type of bacteria that you're dealing with has a recommended countable range, a low and a high CFU, that it's recommended that you count those bacteria within those ranges to get good results. So transitioning over into Petrifilm interpretation, I swear I could talk about Petrifilm interpretation all day. Unfortunately, you nor I don't have all day. We just have this webinar. So we've narrowed it down into some of the more difficult interpretations for Petrifilm, being Enterobacteriaceae or EB Petrifilm and rapid yeast and mold Petrifilm. So on EB Petrifilm, you got to know what type of colonies you're looking for. So typical colonies on an EB Petrifilm will turn red due to that indicator that's present in that zone. Some of the EB produce gas fermentation from glucose, which you're going to see that red colony with a bubble around it. Some EB colonies will produce acid from the fermentation of glucose, and that's going to look like a red colony with a yellow zone around it. And other EBs are going to do both. They'll produce acid and gas, so you'll see the red colony with bubble and a yellow zone around it. So the EB family is a really large bacterial family, which is why you've got these certain types of reactions forming. They all react with the glucose, which is present in the nutrients that are in that plating zone. So you want to be aware of all types of colonies that are red, those with bubbles, those without bubbles, but do produce the yellow acid, or those that have both bubbles and the yellow zones. So this is an example of an EB Petrifilm plate. On the left, you've got a 10 dilution. In the middle, you've got 100 dilution. And on the right, you've got 1,000 dilution. So this interpretation is pretty straightforward and easy. You can see those red colonies there with the gas bubbles. You can also tell that there is a faint yellow zone around those. And when your plates look like this, it's very easy, very black and white. And most of the time your product ends up looking like this, and it's very nice for interpretation. However, there are some samples that can cause you some troubles. Particularly, I notice that environmental samples can be tricky to interpret. So that could show up as some of these options. So if you're looking at these two plates here, you'll see that color change. So the plates are no longer purple, they're yellow. And to someone, they might interpret just looking at this 10 dilution as TNTC. However, when we add in a 100 dilution to these plates, you don't see any growth. So surely if you had a true TNTC situation on a 10 dilution, you would expect some growth to be present on the 100 dilution. So as a technician reading these, you would start to question, was there some sort of lab error? Was there some swap when they set up the samples where they didn't do something correctly? But that's not necessarily the case. So when you have something like this where that first film is very yellow and then you don't have any growth on your 10 or 100 plates, the color change on the 10 dilution could be due to residual sanitizers, background microflora, or pHing issues that can cause that yellow color to occur. So it's not necessarily TNTC-EB, but it is proving that it is really beneficial to do more dilutions rather than just that 10 dilution, because that's not necessarily giving you all that information that you need. So a 10 and 100 and even 1,000 is really going to give you a better picture and help you interpret that more accurately. Now, if we have something like this, I'm curious to see how you guys would interpret these two types of plates. So I'm going to go ahead and get a poll started. Take a look at each of these. And let me know how you guys would interpret these two EB Petri films. Is there no growth present, or is it too numerous to count? All right, I see the majority of you have selected no growth present. That's very interesting. So if I take it a step further, keep in mind this is just our 10 dilutions. So taking it one step further, if I add in a 100 dilution, I'm going to relaunch the poll and see if any of your interpretations might have changed. All right, so I see a lot of you have switched over from the no growth present over to too numerous to count. And that really just shows how important that extra dilution is. So we'll continue and take a closer look at this. So this is that same sample. So you'll see in your original 10 dilution, it looks mostly purple. As you add in that 100 dilution, you can start to see this acid development where you have this yellow bright center, and it just intensifies as you increase dilutions. And all of these up to this point is TNTC, too numerous to count. And then finally, when you get to 10 to the 7th to 10 to the 8th, you could finally get something within countable range. So I just want to state the importance of doing these extra dilutions. And if somebody was inexperienced or in a rush, someone looking at that 10 dilution originally could see that this just looks purple and they don't see any defined colonies, and could call that a less than 10. When in reality, if you have extra dilutions, you can see that this ends up being over 100 million. So it's a huge misinterpretation, but I just want you all to be aware of how important these extra dilutions really can be. So when you're talking to your technicians or when you're looking for this yourself, how are you going to differentiate this? So you'll see on the left up here an uninoculated plate. This is totally purple up here. It's easy to see through. There aren't any opaque areas. You can see the grid lines. However, when you look over here on the TNTC Petri film, you have the standard purple around the edge, but you have this concentration in the center of this cloudy kind of yellow appearance. So that should be an indicator to you that further dilutions are going to be necessary so you can get something that looks like this, being TNTC, down to something within the countable range for you. So going over some colony counting tips specific to EB, you're going to want to know that it is possible for the growth of organisms that are not your target organism. So it's important for you to know what you're looking for, what the typical EB looks like, those red colonies with gas or yellowing or both. And you'll want to know that ingredients in your sample can change that nutrient base in that plate and allow other organisms to grow. An example of this would be your starter cultures. For example, something like a lactobacillus that produces acid. That bacteria can lower that pH, and changing that indicator, which is going to change it from purple to yellow on the Petrifilm, which could accidentally be interpreted as TNTC. So that's something to watch out for. You could also have ingredients in the sample that could provide the right nutrients for other bacteria to grow. But when you set up those additional dilutions, the result looks like 0. So as you further dilute out that sample, you're lessening those nutrients provided from your ingredients, and those other microflora aren't able to grow. So you'll see that yellowing in that 10 dilution, but as you dilute it out further, you're taking those nutrients away that were helping those other non-typical organisms grow, and you won't see anything on the 100 or the 1,000 plate. So that's something that can happen as well. So you want to make sure that you are not counting colonies that are atypical. So only count colonies that have that red appearance with the gas or with the acid or with both. You'll also want to be aware of those TNTC plates, as I was just talking about, that can appear as 0 CFU. Very high concentrations of EB colonies will make a film look like there are 0 colonies present. Further dilutions will show, like in the picture represented earlier, more than 1 million or greater as your actual result. So taking the time to do those extra dilutions is going to help you out. And when you come across something like that, you want to look for that yellow color in the center of the film, like we talked about earlier. Switching gears now from EB over to rapid yeast and mold Petrifilm. So yeast on the 3M Petrifilm is going to be small, defined edges, and actually is a little bit raised. If you run your finger over the top of the Petrifilm, it feels like a small bump. They can vary in color. They can be pink, tan, blue, green. There's quite a variance with yeasts. And as far as mold, they're large, diffused edges, flat. They may have a dark center or a foci. They appear very filamentous. They look like a mold trapped underneath the Petrifilm. They're typically blue-green in color. So it's recommended that you incubate your yeast and mold Petrifilm at 25 to 28 degrees C. We typically stick to the 25 degrees C, although there are certain food types that may exhibit better growth and colony formation at 28 degrees C. It's recommended that you incubate stacks no more than 40 films for yeast and mold Petrifilm, and the minimum incubation is going to be 48 hours plus or minus 2 hours. However, at that time, it's noticed that colonies can sometimes appear very faint. So it's recommended that you allow an additional 12 hours of incubation just to really allow those to develop and make sure that your count is going to be accurate. And then again, make sure that you're not counting colonies that are on that foam dam that aren't exposed to those nutrients on that plating surface. So these pictures are mold growth on rapid yeast and mold Petrifilm. Just different types of mold. You'll see some blue ones, you'll see some more green ones, some that are further spread out, some that are smaller, but all of these are what you would expect to see on rapid yeast and mold Petrifilm. These are examples of yeast growth. The one on the right does have some mold growing on the right-hand side. But this picture just represents how you can have that wide variance in different colors. So the one on the left is more tan colored yeast. However, you can have more like on the right where it's green to blue-green colonies for yeast. I would say if you're ever unsure if it is yeast, a good route to take would be performing a gram stain if you're capable of doing that on site. Something that can cause issue when interpreting yeast and mold plates is this indicator dye. The 3M yeast and mold plates contain a phosphatase indicator dye, and all living cells contain phosphatase. Therefore, there's a natural phosphatase reaction in samples that can cause that indicator to react. So the pictures here show some phosphatase reactions. The figure on the left shows a blue uniform background color. You can see several yeast colonies through that, but that would not be TNTC. The two films on the right show these intense blue spots, these pigments. It's typical when you're plating something like spices or if you have product particulate to see these phosphatase reactions where they're pinpoint blue specks. It's important to not miscount these as yeast colonies. Often they look like they're irregularly shaped, whereas yeast should have really nice round edges. So carrying on these enzymatic reactions, certain foods are going to show interference, some will not. That blue uniform background doesn't necessarily mean it's TNTC. Often you're going to see this from cultures that are added to certain products. And also you should know that indicator reaction is not going to prevent yeast or mold to grow. So with that picture there, you can see the yeast colonies present. This slide illustrates the difference between mold overgrowth and a phosphatase reaction. So the two plates on the left have mold overgrowth. They're very filamentous in nature. They look very much like a mold trapped underneath the Petrifilm. However, the ones on the right are just due to that phosphatase indicator reaction. This one for the, let me go back. Yeast versus the phosphatase reactions. The plate on the left has yeast counts and obviously mold colonies. The plate on the right has those intense blue spots, sometimes caused by product particulate, like I said, or spices, certain types of product to cause that. And it's important, like I said, to not count those as yeast colonies. So as far as counting Petrifilm, most Petrifilm have an area of 20 centimeters squared. For example, the APC Petrifilm, the EV Petrifilm. And if you're doing an estimated count, you'll take an average number of colonies and multiply that by the area. So you multiply it by 20. Other Petrifilms are set up with a different area, a different spreader. So the yeast and mold and the staph have a 30 centimeters squared area. So you want to make sure when you're doing your calculations that you take that into, you'll keep that in mind when you're doing calculations so that you have an accurate count. The area that the sample is spread over will affect your results. And if you aren't familiar, 3M does provide interpretation guides, and they are extremely useful. Especially to people who are new to interpreting plates. This is kind of a lifeline. It's very easy to use. They're very user-friendly, and they're specific to each type of Petrifilm and show situations and how to count plates, as well as some simple setup instructions to follow. They're easily accessible. You can find them online. And like I said, I've found them to be a very great resource, especially for training new technicians. And that is all I have for you guys. Thank you so much for joining me today for that Petrifilm use and interpretation webinar. I know we only covered EB and yeast and mold, so we're gonna hang hang back after the webinar. And if you have specific questions regarding different types of Petrifilm, please use that Q&A section, and I'll stick around and answer any questions that you may have. If you missed any of our other webinars, they are available for viewing through our website, CherneyMicro.com/webinars. And we did previous webinars on environmental monitoring, indicators versus pathogens, good laboratory practices and lab safety, and aseptic technique. So please take a chance and check those out if you haven't seen them already. And at this time, I will open it up for questions. We have a question here that says, why can't you refrigerate open pouches? And if you do, is it okay? It's not recommended by 3M to refrigerate these pouches just because we're trying to keep them away from moisture. And fridges tend to have quite a high humidity. So it's not recommended by 3M if you refrigerate those. I also have another question here asking about Staph express plate interpretation. So a Staph plate, you're going to be looking for typically a dark red, almost kind of maroon type of colony. Although any colonies present should be Staph express disked and re-incubated for several more hours. After that, you'll take it out and look to see if that typical pink ring has shown up around your colony. If so, that would indicate a positive. If not, then you would interpret that as negative. If you have any more specific questions about Staph, you can definitely reach out to me and we can have a further conversation regarding that. What are the cons to a rapid yeast and mold plate versus a non-rapid? So I find that the rapid yeast and mold can be a little bit harder to interpret just because of those phosphatase reactions. I don't see that much of an interpretation problem using the regular yeast and mold Petrifilm, but obviously using the rapid one, it's nice to have those accelerated results, have them out a couple days earlier, but they can cause some interpretation issues, I would say. So you have to know how to read the Petrifilm accurately. Does anybody else have any questions at this time? All right, I think that's it then. Thank you guys again so much for your attendance. I really appreciate you all being here. And if you haven't had the chance to check out those other webinars, please do so. And if you have questions regarding other types of Petrifilm, feel free to call me, reach out to me, or our client services team here at Cherney, and we'd really be excited to help you out with any other questions or concerns you might have.